This video is going to have a look at the ion test that you need to be aware of. There are 4 in total. The 5th one is the flame test. Now, the flame test is something we'll do in a different video, and it identifies the metals in ionic compounds. However, we're looking more at the anions in this case, with one exception, that's ammonium. So I'm going to have a look through the ion test. The key bit here is that you need to explain the test and positive result. So first one is going to be calcium or carbonates in general. We're going to use calcium carbonate just to show our point. So calcium carbonate is quite a common one. If I mix it with hydrochloric acid, so you have to mix this with a strong acid, you are going to get calcium chloride, which is my salt. They like to ask this question because of this compound. Calcium has a 2+ charge, chloride has a 1- charge, so you need 2 1- minuses to balance out the 2+. They like to do that because often people forget that 2+ and they don't balance the rest of the equation properly, and then they lose both marks. You're going to get water, but you're also going to get carbon dioxide. And as you'll hopefully remember, the test for carbon dioxide is the lime water test. So you get a delivery tube, you bubble the gas through the lime water. If it goes cloudy, you've got carbon dioxide. And this is sort of done indirectly. So if I get carbon dioxide, that means that I've got a carbonate, because the carbonates react with the acid to produce carbon dioxide. The next test is sulfates. Now, if I take a sulfate, whichever sulfate we want, let's go sodium sulfate, Na2SO4. What I'm going to do is I'm going to add it to barium chloride. Now, barium is a metal that is often, insoluble. Barium chloride is one of the few where it is actually soluble. So, as a result, we mix it with the barium chloride. Now, before we do that, it's really important you add a little bit of hydrochloric acid, or you'll get contaminants in it, and this will affect the results. So, once you've added the hydrochloric acid, you add the barium chloride. Barium chloride is incredibly toxic. However, barium is generally very toxic. However, barium is generally insoluble, as I've already said. That means we actually use barium for things like barium meals, which the barium shows up on an X-ray. So they use it quite often for people with intestinal issues because it can identify blockages in the intestines. So it is insoluble, it doesn't get absorbed, and therefore it's quite safe. When we mix these two together, we will get the sodium chloride from the sodium here and the chlorine here, and we'll get the barium sulfate, and that barium sulfate is going to be solid. So the positive result of the test for the sulfate is a white precipitate. This one is also a precipitate test, and it uses silver nitrate as my reagent. Now, I'm going to mix that with, let's just say, we could even go sodium chloride again. So I mix it with sodium chloride, and this is going to react with the chloride ion here. This is just like the previous one. This is a precipitation reaction, and the silver and the chlorine will bond together, which will form AgCl, and that will leave me with these two spectator ions, so sodium nitrate. Now, if this is sodium bromide, this will be silver bromide. If this is sodium iodide, this will be silver iodide. Now, colour is the bit that gives this away. So chlorides give a white precipitate, bromides give a yellow one, a cream one, and iodides give a yellow one. So that's white for chloride, cream for bromide, yellow for iodide. When you do this, these two can be quite difficult to tell, and you already judged that from what I've just said, where I've got it wrong. Now, the reason that's the case is because they are quite similar. So there is another test to add on to this. If I add dilute ammonia, this will dissolve. These two won't. If I add concentrated ammonia, this will dissolve and this won't. So that's the next step in identifying the difference between the chloride, the bromide, and the iodide. So first of all, white, cream, yellow dissolves in dilute ammonia. Concentrated ammonia doesn't dissolve. Last one is the ammonium. And ammonium you can actually get away with generally just saying you can recognise the smell, because it's a very, very distinctive smell. However, there is another way of doing it, and this is something just a bit careful about when you're doing it. So you gently warm it up with a Bunsen burner. That will make it evaporate. You get some damp red litmus paper, and that will make the litmus paper go blue because the ammonium is a base, and therefore it will go from red to blue.